Welcome to our session on estimation, sampling, and hypothesis testing. Estimation, sampling, and hypothesis testing. Now, we're going to use the standard normal table to explain the Z values, and also I'll teach you a memory song that you use to apply on most of the hypothesis testing questions. So to start with, a hypothesis is simply a claim that is subject to statistical proof. Many of the assumptions that are made that are without validation require to be substantiated using a test called hypothesis testing. Now, hypothesis testing has a number of steps that you need to follow. To start with, you need to state your assumption to be tested, your hypothesis to be tested. Then number two, you need to state your test statistic. Then number three, you need to compare the test statistic to the critical regions. You can draw conclusions from. Then you can calculate your Z or P value and make a conclusion. Now, every layman who would want to start this lesson must understand that there are a lot of assumptions that we make in life. Doctors make assumptions. So we're firstly going to look at this table that we need to understand. They are what we call confidence levels and significance levels. They will help us find the alpha and Z. A recap of our song. What confidence levels do we have? Number one, 99%, then followed by 98, 95, and 90. The difference from 100 is called the significance level. So here we have 1%. Here we have 2%. Here we have what? 5%. And finally, here we have 10%. Then the alpha is when we divide our significance level by 100. So 0.01, 0.02, and 0.05. And here we have 0.10. And the Z, without alpha over 2, we're going to get what? This one, 2.58, 2.33, 1.96, and 1.645. So hypothesis is simply a claim that must be tested. For instance, you work for Choma Milling and you claim that a 10 kg bag of mini meal inscribed actually weighs to 10 kgs. So you want to test, and after we sampled about 6 of them, we found that they're actually weighing 6 kgs. Now, the customer wants to take you to CCP, what's that, consumer protection. We want to see whether there's a negligible amount that is suable or not. So we said hypothesis testing has how many steps? 5 steps. Number one, you need to set the hypothesis. Our hypothesis is denoted by our HO, which is a null hypothesis, and our HA, which is the alternative hypothesis. In the second step, you need to state your level of significance. Then step 3, you need to make your decision rule based on the levels of significance. And the fourth step, you need to calculate our Z calculated, which is given by our X minus the mu divided by our standard deviation and the square root of n. We only use Z when our sample size is greater than 30. Otherwise, we use a t code to explain later on. In step 5, make a conclusion. I want you to follow me closely because this might sound complex, but very easy as we get to go along the way. But I need you to help me with one thing. I need you to master this table. especially for those that are new. All right, maybe let's do a quick exercise. We have confidence levels, impact level, alpha, and our Z. And the ladies lead us through the confidence levels. 99, then
98, 95, 90.
Then the significance levels, ladies. 1, then
2,
5, 10.
simply the difference from 100. The two must add up to 100. Then the alpha, ladies.
0.01.
0.01.
0.01. 0.02. 0.05. 0.10.
You're just dividing this by 100. And our Z alpha over 2, what do we get here? Ladies, this one is what? 2.58. The gents can finish up. Then here,
2.33, 1.96, and 1.65 or 1.645.
excellent. So the song is as two consecutive, they are all two tools, 2.25, 2.58, 2.33, 1.96, 1.645. So based on that,
Collins, I missed the Z column. What is happening there? Sorry.
now memorize these figures there. We have 2.58 is the answer for any of these three. So 99 is equal to 2.58, 98 is equal to 2.33, 95 is equal to 1.96, and 90% is 1.645. So this is what you need to know for now. Don't ask me where they're coming from. And the signs for this is just equal to or not equal to. That's all. So examiner will ask you to say, this claim that each town records about 100 COVID cases. A sample of 36 towns were found to have, on average, 105 cases of COVID-19 with a standard deviation of 12 people. Use a confidence level of 95% to test whether this claim is true. So now you need to complete this by conducting a hypothesis test. So I need you to understand that you always be given two means. One mean is assumption. It's a hypothetical mean. It says it is believed that 100 patients are found of COVID-19. And when we went to the 6 hospital, we actually found 105. Already you can see the variation of what? The variation of 5 patients. So we want to see whether it is true or not. Okay. So now we're going to conduct a test. So the hypothetical mean is simply a claim which has no substance of the sample size. Whenever you hear to say it is assumed that civil servants get 6,000, then you sample 100 civil servants and they're actually getting 7,000. The 6,000 is your mu, it's just an assumption. But the 7,000 is your X bar because there's a sample size. So these two move together. So step one, we set the hypothesis. What is our hypothesis? our mu is equal to what? 100. And here we say our mu is not equal to 100. Step 2, we set the level of significance. What is our level of significance here? 5%. And we know what is the Z at 5%? 1.96. Then step 3, we draw the critical areas. And these critical areas are very important because they help us identify whether to reject or to accept HO. Here put 1.96 on the negative side, and here put 1.96 on the positive side. So when your answer falls inside the accept region, it means there's no significant difference. They're the same. 105 and 100 are just the same, so they're not lying. If it falls in the shaded region, we call this the rejection region. And when the answer is in this region, we say there's a significant difference. You are lying. 100 is not the same as what? 105. So that is step number 3. Step number 4, we calculate the Z now. Our Z calculated is x bar minus mu standard deviation over square root of n. So our x bar is 105. Our mu is 100. Our standard deviation is 12. Then the square root of n, our n is 36. 105 minus 100, we get a 5. 36 is 6 into 12. What do we get? 2. So when we divide the 2 into 5, we get a 2.5. So we identify where is the 2.5 there? 2.5 is somewhere here in the what? Shaded region. So what is our conclusion? Step 5, our conclusion is what? Since Z calculated is greater than 1.96. What is our conclusion? We reject HO. What does this mean? There's a significant difference. It means there's a significant what? Difference. So it means no, the claim that yeah, on average 100 patients of COVID is not true. So we need to really understand how we are moving. All right. So again, another question would come to say, there is a claim that civil servants get 6,000 or 6 kwacha. Somebody claims that they get 6 kwacha. But after sampling 64 civil servants, we actually found that they actually get 5,000 kwacha. Okay, they actually get 5,000 kwacha. Or we can put here they get 60 kwacha, here they get 50 kwacha. And after sampling 64, we found that they get 60 kwacha. Then with the standard deviation of 24. With the standard deviation of 24. We actually found they got 56 kwacha. Test at alpha 0.02. Test at alpha 0.02. We're going to conduct a test the way we did it. Step 1, state the hypothesis. Somebody help me. What is our hypothesis? Our mu is got what?
60.
60, correct. And here mu is not equal to what? We set our level of significance. What is our level of significance here?
The 2.33.
2%, meaning our Z is what? 2.33. which is coming from this. In step 3, we shade bell shape. So on the left side, we put a negative 2.33. The right side, we put a positive 2.33. So we shade this side, we shade this side. All right. Then step 4, we calculate our Z. How to calculate the Z? X minus mu over standard deviation, square root of n. So what do we get here? Our X bar is what? 56. And our mu is what? 60. And our standard deviation is 24 over square root of 64. Let me calculate what is our Z.
I think 1.33. Negative, is
Okay.
it negative 1.33?
Negative 1.33. So let's identify where is negative 1.33.
It's on the left side of negative 2 point, no, it's supposed to be on the right side.
On the left side, you're right. Where exactly? Inside or outside the shaded region? Somewhere here, right?
Yeah.
Inside. So this is the accept region. So what is our conclusion?
We accept the claim that the mu is that's the claim that the mu is equal to 60.
This means there's no significant difference, right? So we accept the claim. Okay. We accept the claim, correct. Are we moving together so far?
Yes, but for me, I found the Z going to be 1.
When you subtract this, we're going to get negative what? Negative 4. These ones, we're going to get 8 into 24 is 3. So we're going to get negative 1.33. Correct. Okay, I'm building up slowly. I want you to understand the concept. I'm building up slowly. I want you to understand the concept. Okay, can we proceed? So now we are going to look at another question. So we are told, suppose I want you guys to lead me. It is believed the manager for Chuma Milling claims that a bag of milling meal will weigh 10 kgs. After weighing a sample of 49 bags, we found that the actual weight was what? 8 kgs. With a standard deviation of 14 kg. Test the claim at 90% confidence interval. Test this claim at 90% confidence interval. Lead us through step 1. Can you lead us through step 1? State the hypothesis. So what do we put in the hypothesis? One is a hypothesis. So what do we put in the hypothesis?
The mu is equal to that's the h of the now hypothesis is mu is equal to 10 kg. And the alternate hypothesis mu is not equal to 10 kg.
Okay, correct. Now to help step 2, we do. Step 2.
The significance level is 10%, which is 1.645.
Correct. Next step.
We shed the regions. That's on the left, negative 1.645. On the right, positive 1.645.
And step 4.
Calculate the Z score, which will be our mean. Mean minus mu over standard deviation over a square root of n, which will give us the mean being 8 minus 10 divided by 14 over the square root of 49.
What do we get?
On top, it will be negative 2, 7 into 14, 2, yeah, that's 1, negative 1.
So what do we put?
Negative 1, the location is below for negative, it's above the 1.65.
So what's the conclusion?
It's in the acceptance region, so there is no much significance we accept.
The other term for accept is to fail to reject. So we fail to reject, or we can say we accept each one. So this carries about 15 marks. It's one of the major topics in your course, so you need to really understand the steps. I'm very happy with your understanding so far. So now here are the way the questions come in. So we need to now answer this step by step. Okay, so let's apply everything we've just learned and identify the things and the parameters that I just asked you to identify. So we're given this question to say,
Sir Collins,
yes, sir.
just a minute. How are the numbers moving, sir? Number line, are we on the left side? We are going further away from the one, isn't it?
So number line is as follows. The number line looks like this. There's 0 there, there's -1 there, -2 there, upward. So here -1 comes before -1.6. Okay. Here they're increasing. So -1 is inside here. It can't be above there because we're going to the side. All together.
Negative, the one we have -1.645.
It's ahead. It's this side. It's in the yes, 1 comes first.
Okay, so Papa, the first slash where you have started shading, what is that?
1 point here. This is what 1.65. And this is 1.645.
Yes.
Where is 1 here? Is it this side or this side? Where is -1? This is a negative.
So the -1 is falling under the shaded area, isn't it?
No, it's inside. It comes before the -1.6.
Oh, okay. Oh, -1. Okay. I get it. Oh.
Okay, now let's look at this question. A company claims that on average time a number customer wait on hold is less than 5 minutes. Example of 35 has an average of 4.78. Assume the population has a standard deviation of 1.8. So let's identify here. Help me identify the mu, help me identify the n, and help me identify the x bar. So looking at the telecommunication company, it says on average, a customer waits for 5 minutes. Example of 35 customers and an average of 4.78. So help me, which one is the mu and which one is our x bar?
The mu is the claim by the company itself, the 5 minutes, and the X bar is the 4.78. The N is 35.
How do you know this was the x bar?
Because they are saying the company that claims the average. So from the use of the word claim.
Okay, that's one way. The way is the sample size always moves with the x bar. So this one was actually calculated from the 35 customers. So that's how you know. But A is at 0.05 significance. All right. So let's test at 0.05. Let's take step one. The hypothesis. What's the hypothesis? Mu is equal to what? 5. Alternative, mu is not equal to 5. Step number 2. The level of significance. What is our level of significance?
0.05.
5%. Meaning our Z is what?
1.96.
1.96. Okay. Step 3. We illustrate our what? Our critical values. These are critical values. 1.96 and here positive 1.96. What do? We calculate our Z. We calculate the Z. Z is equal to what? X bar minus mu over standard deviation root of n. So what is our x bar?
4.75.
4.7 what? 8 minus our mu
Is there sound?
5. Yes. Then our standard deviation was what? 1.8. And the n is what? 35. Let's calculate the z. Calculate the z. Calculate. What is our z?
Okay, 0.72368.
Okay. Same.
negative 0.72368.
Okay. So negative 0.7328. So where is it identified?
Okay, 0.723.
0.72.
Two.
So it's inside somewhere, right? So what's the conclusion?
Yes. We fail to reject or we accept.
Mhm. Okay. So we accept. Let's look at the second question. Second question. We have a random sample of 20 graduates who worked an average of what? 3.5.
Collins, before you proceed, so what we solved all the 3 questions on question 1, right?
Yes, we've solved all of them.
All right.
I just haven't done the p-value. I'll teach you later on, but we've solved everything. Okay, question number 2, who wants to try? Help me identify firstly our mu, our x bar, our n, our z, and our standard deviation. Just these 4, these 5. Please speak now.
N is 20.
N is 20.
Is 3 point, what's 13.5.
What is 13.5?
This one showing average.
The 13.5 is our what now?
X bar.
X bar. Why is X bar?
Because it was calculated using the sample.
It was calculated from the 20. Excellent. What else do we have?
The X bar is not same as the mean, Mr. Collins.
Two means, even mu is the mean. So we need you to specify which of the two means. Is it X bar or mu? Okay, I need the mu as well. What else do we have?
The standard deviation at 5 hours.
Standard deviation at what? 5 hours, okay. So ST is equal to 5 hours. What else?
The mu is 15 hours in part 1.
Part 1, what is our mu?
15 hours.
Okay, 15 hours. So what is our mu? 15. That's our Z part 1.
Z is 0.2%, which is a 2.33.
2.33. Okay, so let's conduct our test. Right, so we have established that our N is what? 20, our mu is 15, and our Z is 2.33, and our what else did we establish? Our S is 5, and our x bar is 5. Please, I'll give you a few minutes to conduct the test. So mu is equal to 15. Mu is not equal to 15. Yes. Step 1. Step 2.
Our significance level is 2%, which gives us 2.3.
So our significance level is what? 2.33.
Then we sketch.
Mhm. Yes.
And on the right side, positive 2.3. Z calculated. 13.5 minus 15.
So we have what? 10.5 minus 15 divided by
Divided by 5 over the square root of 20.
So that is 5 divided by square root of what? 20. What do you find?
I don't know what others found. On top, it would be negative 1.5 over 5 over the square root of 20. So 13.5 minus 15 divided by 5 over square root of 20 is giving me 0.08359.
Okay.
Alternatively, yes, negative 1.3416. Let me just punch the figures.
What's the final answer? Just help him, those with calculators.
If we can go with negative 1.3416.
1.34. So let's identify where does it fall?
It's in the unshaded area before 2.3.
So what is our conclusion?
We fail to reject or we accept.
So at a significant level of 2%, we fail to reject. HR.
Screaming. Even neighbors would be wondering what's happening to a child in the night.
All right. So this is what hypothesis testing is all about. This is what hypothesis testing is all about. I'll send you some work to do just based on what has been done. So it's hypothesis testing 1.